Okay, for this question, we are going to utilize a calculator so we can come up with a table of values and we'll be able to see what the limit of x approaching 0 plus of x to the x should be, right? So, of course, let's go ahead and come up with our table. And we just have to remember, okay, we have to have the x values. And of course, this right here is x to the x power. And especially since x is approaching 0 plus, you have to know what are the x values that we have to plug in, right? And let me just make a note right here. Suppose you pick x to be exact 0, right? If you put x to be exact 0 right here and right here, you are ending up with 0 to the 0's power. And the truth for this is that, in fact, you do not have an answer for this. So this right here is undefined, right? This right here is undefined. And in fact, when we are dealing with limit right here, it doesn't mean that the limit does not exist. You will see the answer is going to be slightly different than this. This does not tell you anything about the limit, right? Later on, we'll see this is going to be an indeterminate form when we have a limit. All right, so let's see. I'm just going to come up with several values so we can see how this behaves. And I chose this for you guys already. 0.01, 0.001, 0.0001, and then 0.00001. And all we have to do is put this in here and here, of course. So you end up with 0.01 to the 0.01 power. And the answer for that, in fact, it's going to be 0.95499, and so on, so on, so on. So let me just write down the first 5 digits. Actually, I'll put down another digit after that. Right? So the first 6 digits after the decimal point. And then for the other one, when we have 0.001, put it here, we get 0.993116, and so on, so on, so on. And then, of course, you just pretty much do the rest of the work. You get 0.999079, and so on, so on, so on. And then one more for the last one that I have for you guys is 0.99988. 4, and so on, so on, so on. And I'm not rounding, I'm just putting down the first 6 digits after the decimal point, all right? So this is it. And as you can see, when x is getting closer and closer to 0, these values are getting closer and closer to 1. Therefore, the limit as x approaching 0 plus of x to the x power is equal to 1 right here, right? So now, let me just make this super clear for you guys. This right here is indeed equal to 1 because I can show you guys the graph of x to the x power. And of course, you can do that on your graphing calculator as well. But let me just give you guys a quick sketch of how the graph looks like. Well, if you are graphing y is equal to x to the x power, this is not exponential, this is not polynomial, or not power function. It's like both, right? This is the power tower function, x to the x power, like that. Anyway, when x is equal to 0, in fact, you have an open circle right here. Because when x is exactly 0, x to the x power, namely 0 to 0's power, is undefined, right? So you actually have an open circle right here. And interesting enough, the y value right here is equal to 1. And if you look at your graphing calculator, you will see the curve actually goes like this. It actually goes down a little bit, and then it goes up, right? And of course, when x is exactly equal to 1, you have 1 to the first power, so you have 1. So it's like this. And it's not meant to be like a nice parabola. Let me just make it slightly like this. It's slightly, this is 9 in the middle, so it's like this, right? Really crazy stuff, and we'll investigate this function a little bit more later on. And again, if you have this, and suppose I call this to be f of x, to be x to the x power, again, notice if we have f of 0. Again, this right here means we put 0 into the x here and here. It means we get 0 to the 0. But the problem for this right here is, this right here is undefined. We do not have an answer for this, right? We do not have an answer for this. So I'll just put this down right here as a note. And then here's the second note. Based on what we got, if we are talking about the limit as x approaching 0 plus, of the function f of x, which is, you can put x to the x power here. The answer to this right here is indeed equal to 1, right? So that's pretty much what we got right there. So that's it.